Okay, for problem number 10, I went ahead and kind of drew this out right here. They want us to find, or they told us, I'm sorry, that the top of the ladder is sliding down the wall at a rate of 1.2 meters per second. They want us to find the rate at which the base of the ladder is kicking out away from the wall at the moment when h is equal to 3. That should be meters there. So I went ahead and redrew this and just reminded everybody that x is actually growing now. As the ladder is sliding down the wall, h is actually shrinking. The one thing I wanted to point out here that I went ahead and wrote out already that I should discuss, dH dt here, guys, has to be a negative quantity. H represents the variable distance between the base of the wall and the top of the ladder. So as the bottom of the ladder is sliding out away from the wall in this direction, h has to be coming downward, which means that h is decreasing over time, and its derivative, therefore, has to be negative. I would expect that if I gave you guys a problem like this on a test, a lot of you guys would do everything right, except a lot of people would have given me a positive 1.2 for that dH dt. Okay, just like in number 9, we're going to go ahead and use the Pythagorean theorem to set up this equation right here. So I'm going to go with, whatever order you want to do this in is fine, x squared plus h squared is equal to, and again, because the hypotenuse is fixed here at 5 meters, I can go ahead and do 5 squared, which is just 25. I don't need a variable there because that 5 meters is not a time-specific value. Cool. So let's go ahead and let's differentiate both sides of this. We're going to get a 2x multiplied by a dx dt there, plus a 2h multiplied by a dH dt is equal to 0. That's the exact same derivative equation that we had in number 9. And now let's fill some things in right here. Now again, what we are looking for is the value of dx dt. This is the unknown here. That means that we better know the value of x and the value of h and the value of dH dt at the moment in question. So they gave us dH dt, not worried about that. They told us what h is at the moment here. The hard part is going to be coming up with this x right here as well, but I'm hoping you guys recognized what was happening here pretty quickly. At the moment in question, h over here on the left-hand side is equal to 3 meters. Your hypotenuse is still going to be 5 meters, so we could definitely use the Pythagorean theorem like we had to do in number 9 to figure out the other leg, but I'm hoping you guys recognized this is a Pythagorean triple, and of course the most common of all Pythagorean triples, 3, 4, 5. So at the moment when h is equal to 3 meters, x is equal to 4 meters, and that tells us everything that we needed to know. So let's fill it all in, guys. 2 times an x value of 4. Let me say this again. 4 is a time-specific value. You can only use it after you've taken your derivative, which we did right here, and that's why I drew that little dotted line. So now it's okay to put in time-specific values. We don't know dx dt, that's what we're looking for. Plus 2 times a height value of 3 meters, and once again, that's time-specific, but we can use it because we've already differentiated. Multiplying by dH dt, which is a negative 1.2, gotcha, all of which is equal to 0. Okay, what can we do here, guys? The 2 times 4 times the dx dt is going to be an 8 dx dt. Gotcha. I'm going to do two things at once, guys. This looks easy enough to do mentally. 2 times 3 is 6. 6 times 12 is 72. So times 1.2 would be a negative 7.2, which I'm now going to bring over to the right side and make it a positive 7.2. And then, the only thing we have to do right there is divide both sides by 8, and if I'm not mistaken, I think we can do this without a calculator right here, guys. If I multiply both of these by 10, for example, that'd be 72 over 80. I would divide the 8 out and get 9/10. That's where we're at right here, guys. So dx dt, I'm going to write it as a fraction here, 9/10. But of course, you guys probably went to your calculator and got it as a decimal, which is 0.9. Either of those would be fine. So 9/10 meters per second. And last thing, does it make sense that the answer is positive? Well, since x is growing as this problem goes on, yeah, a positive derivative is exactly what we should be seeing here. So 9/10 or 0.9, however you want to do it, that's your answer for number 10.